Alright, everybody, this is lesson 1.3. I'm a little sick today, so please excuse the sniffles and if I sound a little nasally. So, this lesson, we're going to continue talking about radicals, but specifically, we're going to talk about radical operations, so how to add, subtract, multiply, and divide radicals. So, first, we'll talk about adding and subtracting. The steps that we use to do that are outlined here. The first thing that you want to do is simplify all of the radicals. The second thing you want to do is identify radicals with the same index and the same radicand. They have to have both, only these can be combined. And then for common radicals, you'll add and subtract the coefficients and keep the common radical. So let's do number 1 to see what this looks like. So the first step is to simplify the radicals. So I'm going to do that with our factor trees that we were using last time. So 27 breaks down into 9 and 3. 9 is 3 and 3. Our index is 2, so we'll do groups of 2. 1, 3 left over. So this is going to become 3 times 3 square root of 3, which is 9 square root of 3. This other one, 12, breaks down into 4 and 3. 4 is 2 and 2. Our index there is also a 2. It's looking for groups of 2 things. So we got the 2's, the 3 left over. So this will become negative 2 times the 2 from the group. Square root of 3, because that's what's left over. So this will become minus 4 square root of 3. So all I did there was simplify the radicals. And then the next step is to identify radicals with the same index and the same radicand. Well, both of these are square roots, so our indices are the same, and then they both have a 3 as the radicand, so we know we can combine them. And step 3 says for common radicals, add and subtract the coefficients. So remember, these numbers out front are the coefficients, and keep the radical the same. And that's the reason the radical has to be the same, is because it will remain the same the whole time. So 9 minus 4 is 5. And then that radical remains the same, which is the square root of 3. So that expression can be simplified down to 5 square root of 3. Alright, number 2, we'll go ahead and do the same thing. So we will need some factors of 54, which we'll use 6 and 9. Remember, you can use any factors and arrive at the same result. 6 is 3 and 2, 9 is 3 and 3. Our index is 3, so we're looking for groups of 3 things. So we got 3 3's and a 2 left over. So this one will become 3 times the 3 from the group, and then the cube root of the 2 that's left over. 3 times 3 is 9, so that'll be 9 cube root of 2. The next one doesn't simplify because 2 is prime, so we'll do subtract 2 cube root of 2. And then this one, I'm going to go ahead and just move that negative out front like we talked about last time. And then 16 is 4 and 4, which are each 2 and 2. We're looking for groups of 3. So we have 3 2's, 1 left over, so this is going to be negative. Oh, sorry, I'll do it up here. This is going to be negative 7 times the 2 we can pull out, and then we have the cube root of 2. So negative 7 times 2 is 14, cube root of 2. Okay, so we simplified all of our radicals, and then we're going to look for radicals that have the same index and the same radicand. Well, fortunately for us, all of these are cube roots of 2, so we can combine them. So we'll just go ahead and combine their coefficients. So 9 subtract 2 is 7, subtract 14 is going to be negative 7 cube root of 2. Maybe I'll box these so that the answer's a little easier to find. Awesome. Number 3. So again, we just got to break down our radicals. So 48 is going to be 4 and 12. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. Looking for groups of 4. Looks like we've got 4 2s and a 3 left over. So that's going to be 7 times 2, 4th root of 3, which will be 14, 4th root of 3. The next one doesn't break down because 3 is prime, so we'll have -2, 4th root of 3. And then 72, that is 8 and 9. 8 is 4 and 2. 4 is 2 and 2. 9 is 3 and 3. Looking for groups of 3 things this time. So we've got 3 2s and then 2 3s left over. So if we simplify that, we're going to have the 3 that was already there multiplied by a 2 from the group. And then we'll have the cube root of 3 times 3 left over. 3 times 2 is 6. Cube root of 9. Alright, so looking at these, we're looking for things that have the same index and the same radicand. So it looks like these two here have the same index and radicand, so we can combine those. So we'll just combine their coefficients. 14 minus 2 is 12. So we've got 12. Oh, sorry, it's not a 4th root here. This is a cube root. This is a 4th root of 3 minus 6 cube root of 9. Since that last one doesn't have the same index and radicand, we can't actually combine them, so they just have to remain separate. So I'll go ahead and box that. Alright, and this is your favorite moment. This is when you go ahead and pause the video and do this one on your own. Okay, this is going to simplify to 20 square root 7, and then 2 cube, -2 cube root of 7, and then this next one will be 20 square root 7. These two are the same, so we can combine them. Even though they all have the same radicand, you got to make sure that they all have the same index as well. 20 minus 20 is 0, so these actually go away, and we're just left with -2 cube root of 7. That is our final answer. Hopefully you got that. If not, that's okay. We'll keep going. Alright, now we're going to introduce some variables into the mix. But remember, the process is the same. So some factors of 98. That's not one I'm very familiar with. Let's do 2 and 49, and then 49 will be 7 and 7. Our index is 2, so groups of 2 things. So we've got the 7s with the 2 left over. So we can pull out the 7, and then we've got 4 x's, which is 2 groups of 2. So we'll have x squared on the outside, and then y squared, or 2 y's, which is 1 group of 2. So we'll have a y on the outside. So we'll just be left over with the 2 on the inside. And then the next one, what's left in the radicand is prime, so we can't simplify that, so this will be subtract 3x squared y square root 2. Okay. So looking at our radicals, we've got the same index and the same radicand. What's important here is you also actually have to have the same variables out front. Unfortunately for us that we do. So we can combine our coefficients. So 7 minus 3 is 4. So we get 4x squared y square root 2. Alright, the next one. Interesting. Okay, let's see what happens here. So we'll go ahead and move that negative out front. 40 will break down into 4 and 10. 4 is 2 and 2. 10 is 2 and 5. Our index is 3, so we're looking for groups of 3. So we'll pull that 2 out, so we'll have negative, our negative from before, and a 2. We have 7 A's, which is 2 groups of 3 with 1 left over. Maybe I'll write 1 up there to remind me. And then inside of our cube root, we have 5A. Okay, over here, this is just showing this as the coefficient, our coefficient, or like this is all out front of our radical, 2A squared. So let's simplify this down. 135, let's see. Let's do 5 and 27. 27 is 3 and 9, which is 3 and 3. Our index is a 3, so we want groups of 3 things. So let's see, we have, oh, we don't want that color. We've got the 2 that was already out front times the 3 from our group. And then we've got 4 A's, which is 1 group of 3. So we'll plot 1A along with the A's that are already out there, so those 2 A's. So we'll just have 1A left over inside, so this would be the cube root of 5A. I'm going to go ahead and rewrite this by simplify that second one. So the first one remains the same. This will be 2 times 3 is 6. Oh, interesting. That's an 8 cubed. So then A squared times A is A cubed, and then the third root of 5A. So for this one, you'll notice that the index and the radicand are indeed the same, right? Those are the same. But the problem here is that the variable part that is out front is not the same, so these actually cannot be combined. That would be the very end of that problem. We can't combine it or simplify it any further. Okay, so moving on from addition and subtraction, now we're going to talk about how to multiply radicals. So multiplying coefficients, we're going to use the product rule, which is the same product rule we were using in the exponent lessons, because remember, radicals are just exponents. But essentially what it is that you can multiply insides of radicals together. Oh, we scrolled. Sorry. Oh, we went to a different page. Sorry. And we're back. Alright. So you can multiply insides with insides. That's kind of the big thing that we'll talk about a lot. You can do insides with insides, as long as they have the same index. So the step 1 is to combine them, and then step 2 is to simplify. So number 7 here, I am so sorry, I don't know why that's happening. So number 7, we have the square root of 27 times the square root of 5. And as we saw earlier, you can only combine them if they have the same index. These ones do have the same index, it's a 2, so we'll go ahead and just multiply their insides. 27 times 5 is 135, so this becomes the square root of 135. But that's not our final answer because we want to write it in the simplest form, so we'll just use our factor tree to simplify that. So we know some factors are 27 and 5. 27 breaks down into 9 and 3. 3 breaks down into 3 and 3. Our index is a 2, so we're looking for groups of 2 things will be left over. Our leftovers will be a 3 and a 5. So writing this in a simplified form, we can take a 3 out, and then inside we'll have 3 times 5, which is 15. So the square root of 27 times the square root of 5 simplifies to 3 square root 15. Awesome. Okay, this next one. So this is, we now have coefficients, and how I like to remember these is you do outsides with outsides and insides with insides. So our 3 and our -2 would be outsides. So outsides with ousides, we can do 3 times -2. I don't write it like that. 3 times -2 is -6. And then insides with insides, since those have the same index, and 10 times 18 is 180. And then we want to write it in its simplest form. So 180 breaks down into 18 and 10. 10 is 2 and 5. 18 is 9 and 2. 9 is 3 and 3. Our index is 2, so groups of 2 things. So we'll be left over with a 5. So this will become -6 times 3 times 2 times the square root of 5. 6 times 3 is 18, times 2 is 36. So this will be -36 square root of 5. Alright, next one, number 9. So again, we've got some coefficients here. So we're going to do outsides with outsides, inside with insides. So we'll start with the outsides. 2 times 5 is 10. And then we'll do the insides, since they have the same index. These have the same index, so we can do 9 times 24, which is going to be -216. And then we need to simplify that. So let's see, factors of 216, well, we know that's 9 and 24. 9 is 3 and 3. 24 is 3 and 8. 8 is 4 and 2. And 4 is 2 and 2. Our index is a 3, so we want groups of 3 things. So we got our 3 2s, our 3 3s with nothing left over. So this is gonna be, I should have remembered. What do we do with that negative? We move it out front, right? So we'll just go ahead and move it now. So we'll make that positive and put the negative out front. So simplifying this, we'll have -10 times a representative from each group. So times 3 times 2. And then there's nothing left over. So this one actually does just simplify down to -60. Alright, I want you to practice on your own, so go ahead and pause the video and do number 10. Okay, so when you multiply these together, you're going to get 3/4 root of 512. And then when you factor that down, it becomes 12/4 root of 2. Hopefully you got that. If not, that's okay. Okay, let's keep on keeping on. Let's do a couple more examples. These ones have variables. But remember, the principles remain the same always. So outsides with outsides, insides with insides. So doing the outsides here, this one has an imaginary 1. So 1 times 5 is 5. And then they do have the same index, so we can combine their insides. 6 times 8 is 48. And then x to the 4th times x to the 5. Well, that's just our exponent property, and we're going to add those. Like bases that are multiplied, you add their exponents. And then we'll go ahead and just simplify. So 48 breaks down into 4 and 12. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. Our index is a 2, so we want groups of 2 things. We'll have a 3 left over. So rewriting this, we have the 5 that's out front times a 2 from each group. And then let's pull out our x's as well. We have 9 x's and we want groups of 2. That's 4 groups, so we can pull out 4 x's with 1 left over. So left over inside the root is 3x. Simplifying that, 5 times 2 is 10, times 2 is 20, so we've got 20x to the 4th times the square root of 3x. Alright, number 12. We've got no coefficients, just insides. So go ahead and multiply those together. 54 times 5 looks like that's 270. And then we have m to the 8 times n to the 4th, which will add those, so we get m to the 12. Simplifying that, 270 is 27 and 10, which is 9 and 3. 9 breaks down into 3 and 3. 10 breaks down into 2 and 5. Our index is a 3, so we're looking for groups of 3 things. We have a 2 and a 5 left over. So if we simplify this now, we can pull out a 3 from our group. And then I'm also going to look at the variables. There's 12 m's, and we're looking for groups of 3. That would be 4 groups of 3. So we can pull out 4 m's. And then left over inside of our cube root, we have 2 times 5, which is 10. So that would be the most simplified form of that multiplication. Alright, 2 more of those. This next one, we've got insides with insides, since our index is the same. 3 times 36 is 108, so this becomes the cube root of negative 108. 8 to the 7 times 8 to the 6, we add those. 6 plus 7 is 13. And then b to the 4th times b squared, and 4 plus 2 is 6. Awesome. And then we simplify from there. So let's go ahead and start by moving that negative out front. 108 is 9 and 12. 9 is 3 and 3. 12 is 3 and 4. And 4 is 2 and 2. Our index is 3, so groups of 3 things. 2 and 2 are left over. So if we rewrite this, we'll have the negative that we moved out front and the 3 from our group. There's 13 A's, which is 4 groups of 3 with 1 left over. And then there's 6 B's, which is 2 groups of 3 with none left over. So then we'll go ahead and put everything back inside the radical. We've got 2 times 2 left over, which is 4, and then we had 1 A left over. So that would be the simplest form of number 13. Alright, and now it's your turn. Go ahead and pause the video and do number 14. Okay, this simplifies when you multiply them together to be 14 4th root of p to the 5 q to the 11. And then when you simplify that, it becomes 14pq squared times the 4th root of pq cubed. Hopefully these are sinking in. Alright, now we're going to change the kind of multiplication that we've been doing. And now we're going to do what's called a monomial multiplied by a binomial. We'll talk about those words a little bit later, but that's what's happening. So when you multiply, this is the distributive property. So we're going to go ahead and distribute it to the first term and then the second term. So if I were to write this out, it's going to be the square root of 10 times 5 square root of 5, and then plus the square root of 10 times negative 2 square root of 2. You don't have to write it out, but that's just maybe to help you see what's going on. So let's go ahead and do this. And as always, it's insides with insides and outsides with outsides. So let's do this multiplication first. That's going to be, there's an imaginary 1, so 1 times 5 is 5. 10 times 5 is 50. And then let's do this multiplication, so this will be plus, so imaginary 1 times -2 is -2, 10 times 2 is 20, so that one will become -2 square root 20. And then we do have to simplify, and we need to simplify so we can see if we really can add these together or not. So 50 is 5 and 10, 10 is 5 and 2. Looking for groups of 2 things. I'll have a 2 left over, so this will become 5 times 5. The 5 that's already on the outside times the 5 we're pulling out is 25, with the 2 left over. This one is going to be 4 and 5, 2 and 2. Again, looking for groups of 2 things. I'll have 5 left over. So this will become -2 times 2, which is -4, square root 5. And since those don't have the same index and radicand, that is our final answer for this one. Alright, number 15. Now this gets a little more crazy. To multiply these together, you have to do something that we sometimes call foiling, which we're also going to talk about more in depth later. But maybe one way to think about this is the first number has to be multiplied by both things in the second parentheses, and the second number has to be multiplied by everything in the second parentheses. So let's just go ahead and do those one at a time. So the first one is 8 times 3, which is 24. Then we'll do 8 times negative square root of 10, which will be -8 square root of 10. Then we'll go down to that bottom and do negative square root of 10 times 3, which is going to be -3 square root of 10. Remember, you can only do insides with insides and outsides with outsides. So you got to be careful on those. And then finally, we've got negative square root of 10 times a negative square root of 10, which is going to give us positive square root of 100. If we simplify this, well, 10 breaks down into 2 and 5, which means those can't be simplified. So we can't simplify their radicals, but we can combine them, right? They have the same index and the same radicand. When we add and subtract, we combine their coefficients. So -8 minus 3 is -11 square root of 10. And then that last one, the square root of 100, maybe you know that. That's just 10 and 10. So that will be plus 10. And then 24 plus 10, we can totally do that, which is 34. So we'll get 34 minus 11 square root 10. Let's keep going. Number 17, so we're going to have to do that FOIL thing again. So let's do the first one times the first one. So 6 square root 6 times the square root of 6. Insides with insides, outsides with outsides. So 6 times the 1 gives us 6, and then square root of 6 times the square root of 6 is going to be the square root of 36. Then we'll do 6 square root of 6 times square root of 2, which will be 6, since that's 6 times 1, and then square root of 2 times square root of 6 is the square root of 12. And then let's do the second one times the first one. So -6 square root 2 times square root of 6. Well, -6 times 1 is -6. Square root of 2 times the square root of 6 is the square root of 12. And then let's do -6 square root 2 times square root of 2. -6 times that 1 is -6, and then square root of 2 times the square root of 2 is the square root of 4. And then looks like we can combine these two together. Well, fortunately for us, 6 minus 6 is 0. So those terms are actually going to go to 0. They're going to go away. So then we'll just have 6 square root 36 minus 6 square root 4. But the square root of 36 is 6. So this becomes 6 times 6. and the square root of 4 is 2, so that will become 6 times 2. 6 times 6 is 36. 6 times 2 is 12, so 36 minus 12 is 24. So that one simplifies all the way down, a nice number. Alright, number 18. This one's really important. So for number 18, this squared here, we are all going to be tempted to just apply it to everything on the inside, but hear me out right now. That only works when there is only multiplication on the inside. When you are adding and subtracting, that is not a valid thing to do. Instead, you have to remember what a squared means. Well, squared means something times itself. So we're going to rewrite this as 4 subtract the square root of 5 times 4 subtract the square root of 5. And then we're going to use that little FOIL thing where we multiply stuff. So we'll start by doing 4 times 4, which is 16. Then we'll do 4 times the negative square root of 5, and you can only do outsides with outsides and insides with insides. So 4 times negative 1 is negative 4, and then that's just the square root of 5. And then we'll do negative square root of 5 times 4, which is going to be another negative 4 square root of 5. And then we'll do negative square root of 5 times negative square root of 5. Negative times negative is a positive. Square root of 5 times the square root of 5. Those are both insides, so we'll get the square root of 25. Let's go ahead and combine like radicals. Well, these two, I don't know, I'm going to do it in a different color so it's not misleading. These two both are the square root of 5. So since they have the same index and radicand, we can combine them by combining coefficients. So this would be negative 8 square root of 5. And then this is 16. And then the square root of 25, well, we know that that's just 5. And then we can combine that further because we know what 16 plus 5 is, which is 21. So this will be 21 minus 8 square root 5. Alright, now we're introducing some variables. So number 19 here, we've just got to apply this, or distribute it, got to distribute everything inside. So insides with insides, so we can multiply 3k and 12k, which will be 36k squared. And then these two, we would have to do the 1 times the negative 2, so we have negative 2 on the outside. And then insides, 3 times 15 is 45, k times k squared is k cubed. And then we'll go ahead and simplify that. 36 is 6 times 6, so this will just be a 6 out front. And then we're looking for groups of two things, and that's k squared, which means we can pull that out. So I'll have 1k, and then the next one, 45 is 3 and 15, which is 3 and 5. Looking for groups of two things. We got a 5 left over. So this is going to become negative 2 times 3, which is negative 6. And then we have 3 k's and we need groups of 2, so we can pull out 1 k with 1 left over. So we'll have square root of 5k. Excuse me. And since those do not have the same radical, we cannot combine them. It's tempting because these are the same, but the radical part has to be the same too. Alright, I want you to go ahead and try number 20 on your own. Okay, when you FOIL this, you would get the square root of x squared plus the square root of 2x minus the square root of 8x minus the square root of 16. we would have to simplify those. The square root of x squared is going to be x. The square root of 16 is going to be 4. 8, that breaks down into 4 and 2, which is 2 and 2. So we will have 2 square root 2x. Those now have the same radical, so we can combine them. So we'll have x subtract square root 2x subtract 4. And none of those are like things, so that would be our final answer. That was kind of a tricky one, so maybe you got it, and maybe you didn't. That's okay. Okay. Next one, we need to find the area and perimeter of the rectangle shown to the left. So let's find the area first. If you remember, area is length times width, so we're going to do 7 square root 6 plus square root 3 times 4 minus the square root of 6. And then we'll have to go ahead and FOIL. So 7 square root 6 times 4, 7 times 4 is 28. So we'll have 28 square root 6. And then 7 square root 6 times square root 6 is going to be 7 square root 36. And then we'll do the square root of 3 times both. So square root of 3 times 4 is 4 square root 3. And square root of 3 times negative square root 6 is negative square root of 18. Simplifying those, 6 is 3 and 2, so that doesn't break down. 36 is 6 and 6. So this will become 7 times 6 is 42 plus 4 square root 3, and then 18 is 9 and 2, which is 3 and 3. So we get negative 3 square root 2. And I'm just checking my answer here. I felt like I missed something. Right here. I apologize. When we do 7 square root 6 times negative square root 6, this has got to be a negative 7. So this becomes a negative 42. And none of those are the same. So that would be the the area of that box. Kind of a nasty area, but the area nonetheless. And then perimeter, if you remember, perimeter is the sum of all of the sides. So this would be 4 minus square root of 6 plus 7. Well, maybe an easier way to do this is it's a rectangle, so we have 2 of the 4 minus square root 6, and then we have 2 of the 7 square root 6 plus square root 3. If we distribute, we get 8 minus 2 square root 6 plus 14 square root 6 plus 2 square root 3. Remember, outside with outsides, inside with insides. We have some like radicals here, so we can combine these middle two since they're both square root of 6. 14 minus 2 is 12. And then the 2 on the ends don't change. So that right there would be our area.